Hello, everyone. Welcome to another inspiring session of our modulyss Talks. I'm Morgan, your host, and I'm thrilled to have you join us. If this is your first time attending, modulyss Talks is all about educating and informing design industry professionals like you. We explore the latest insights, trends, and innovations to help you elevate your projects, expand your expertise, and this all during your lunch break. Today, we'll be discussing how we overcome acoustical challenges in high traffic areas such as open commercial spaces. Joining us is Remy Wenmakers. He's an acoustic consultant, researcher, and teacher at Level Acoustics and Vibration with a PhD in stage acoustics and extensive experience optimizing sound environments in offices, auditoria, concert venues, and outdoor spaces. Remy combines scientific research with hands-on expertise to develop tailored acoustic solutions. If you have any questions during this talk, pop them into the Q&A and we'll discuss them after the talk. So without further ado, Remy, the stage is yours.
Thank you very much, Morgan, and thank you for inviting us to share our work at modulyss Talks. As explained, I will talk about acoustics in commercial design, acoustics and flooring, of course, because modulyss is all about flooring. And I will also highlight some of our work with flooring in the presentation, together with the broader aspects of sound. So let's dive in. I have 3 projects that I want to talk about today. I saw that there are quite a lot of webinars already about the technical aspects of acoustics, which I highly recommend to also watch, or perhaps you already have seen those. And I thought, well, since we have already learned a lot about the technical aspects, let's see how we have applied those in real solutions. And I've, as I said, selected 3 projects, which are quite recent. One is a concert space, Viva Studios in Manchester. The other one is an office building in a former milk factory in the city of Eindhoven, where our company is housed. And Eindhoven is in the Netherlands, by the way. And also, I will talk about the Van Abbe Museum, which is also in Eindhoven. And as you closely watch, perhaps on the 3 pictures, you already see applications of flooring in these projects. And the fun part is that they can be everywhere, even on the walls and the ceiling. All right, a quick wrap up of what acoustics is about, just for those who haven't watched the other technical talks. And this will be the only slide with bullets. But to quickly recap, so we have in acoustics a couple of themes, you could say, architectural acoustics. One of is room acoustics, so sound is coming from inside the room. For instance, you want to control the reverberation of the room. You might want to optimize the speech and music transfer. You want to control noise, because speech can also be noise. Music can be noise, and equipment can be noisy. And last but not least, walking in the space can also create noise, and that is something you want to control as well. Then thinking about sound insulation, it's the sound that comes from outside the room or is going outside the room. And then we distinguish between airborne noises, such as speech, traffic, music, again, equipment, but also walking or other impact sounds that excite the floor directly. Well, as you've seen, our company is not only working on acoustics, also vibration. And very typical vibration problems are walking on floors that are relatively light and move when you walk, or even jumping when we consider performing art spaces with large groups that can excite the floor of a concert space. But also equipment is often a nuisance for vibrations, traffic, and railroads in particular. Here I highlighted where I think modulyss is an interesting application on all these acoustic themes. So reverberation control, walking noise, and 2 different applications. Okay, let's dive into the factory. The factory is a performing arts center in Manchester. It's hidden here in the picture. Let me highlight it because it's, as you can see, it's in a very dense area of the city with a lot of high-rise buildings around. And you can imagine that if there is a concert or a dance party in this space, you don't want to disturb the neighbors. So that was a big challenge. The concept of the building is quite special because we have a very big box, a rectangular shape, and that is an exhibition space or a concert space for pop concerts, all kinds of concerts with people standing, together with a auditorium with seats, and in those seats, those seats are in a separate box connected to the big box, and you can open doors to allow the big box to be the stage of the auditorium, and that makes it a very flexible building. With this kind of stretch of the building, you can also see that there is a space underneath. There's a road running from left to right under the building. So all the concert spaces are lifted from the ground. Taking a closer look, this is the road underneath the building. And if we go inside, we come into the foyer space that is on the ground floor. And above that foyer space is the big box, the warehouse space, as it is called, where, for instance, people can jump on that floor or be dancing, and there's a lot of noise. There's a special ceiling in this space that makes sure that you're not disturbed in the foyer. A view of the auditorium. I will talk a little bit more about the materials that are used once we go further in the presentation. And a special concept, I think, works very nice in this big theater is that we have a wooden finish that is sound absorbing. But our idea was, how can we make the space dry enough so the speech is intelligible and music sounds dry, what you want in a theater, but also keep some reverberation, keep some reflection. And it turns out that these wooden panels have this very nice absorption of 80%, but also reflection of 20%. So you keep the sound moving in the space. And that's also what the client really appreciates about this room, is that there is still liveliness, even though it's a dry space. Let's have a look into the warehouse. You might almost think that this is a factory space, but that's also a little bit connected to the name of the client, which is Factory International. And they host all kinds of art performances and exhibitions in this space. And as you can see, there's a person here moving a wall element. So the space is 20 meters tall, and you can separate the space into two parts with this movable wall element, which is not a single wall, but actually a double wall. So there are two parts of this wall. Okay, but where did we come from? Because originally, this Factory International organization did not have their own building. So they wanted a space for their own, but they were happy with a lot of, let's say, abandoned or other weird spaces that they could find in the city, because it was very much what they liked, to have this kind of rough interaction of old spaces. But you can imagine how these spaces sound like. This is an old train station. And I went there just to get an idea of what's going on in terms of sound. And let's have a listen. If I click, you should be able to hear a balloon pop in these spaces. Okay, that was the first one. The second one. Okay, so it's clear that these rooms are very reverberant, and that's also what you expect looking at the materials. Everything is rigid and reflective. A reverberation time of 4 seconds. 4 seconds is way too long for performances of music, speech, etc. But the funny thing was that the client said, we don't mind if the acoustics is like this. We can manage. We have loudspeakers. We can direct the loudspeakers. We always do this all the time. You don't have to make our building very nice in terms of acoustics. We can handle any space. Well, we did not really agree with that as an acoustician. So yeah, we really had to push and convince them that they should have a building that has a very dry acoustics, so you can do everything you want. And we will have a closer look at those materials later on. This is the floor plan of the building. So a lot of things I've already talked about. So here in the middle, you can see the double walls that can be open. We think about reverberation control of each space. Which is the green arrow. We have the impact sound on the staircases of the audience. If people walk in the auditorium, you don't want to make disturbance, especially if people come in late and they have high heels, tack, 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 they go on the stairs. That's not what you want. So you also have to control the walking with, of course, a carpet as a finish. In the big space, maybe you want carpet for the acoustics or for the walking noise, but it has to be a space that has to be cleaned easily. You can imagine if there's a big party with beer spilled on the floor, etc., etc. You need a very rigid floor to be able to clean the space. So sometimes that is also a limitation. What else you can see is that there are arrows going out the building. There is a double facade running around the building, especially the warehouse. It is a concrete box with an inner shell and an outer shell and a cavity of about 3 meters. So it's a huge cavity. And you can actually use it as a transport. It's used for people to go around the building if they want to move around the spaces. Okay, let's see what's... Now, I have a couple of solutions I want to discuss and how we look at those things when we think about the acoustic properties. And one of them is the seats in the theater. So we have to know what is the sound absorption of those seats. In the right, you can see the application in the building. On the left, you will see the setup of the same seats in our acoustic laboratory. So in the laboratory, we have a reverberant space. And in that reverberant space, you can add materials to see what is the impact of the materials on the reverberation time. And using a model, we can derive the sound absorption properties of the material. And as what you also see is that we included the carpet between the seats in the test. It was an additional test that we really wanted to do because usually the seats are not tested with the carpet. There's just the seats, which is a bit funny if you think about the application because there's always carpet between the seats. And it turned out that the impact of that extra carpet is not that big, which is in a way good because you don't want also too much sound absorption can also be a problem. So the test was fine. What else we tested is the wooden finish of the auditorium. So on the right hand picture, you see that there is a darker color, of course. So the wood is painted. And on the left, you can see that these wooden panels actually have very small slits. And behind those slits, there is sound absorption. And these slits size together with that absorption creates this nice balance between absorption and reflection that we were looking for. And you can also see that there is a large surface area covered with this material. And so you need a lot of sound absorption to get the acoustics right. Now we look at the materials that we applied in the warehouse, so in the big space and the concert space for pop music. And what you see on the right-hand side is that these materials are really thick. They are about 300 millimeter thick. The blue patches, they are 300 millimeter. And the reason they are this thick is that you can absorb low frequencies only with very thick materials or panel absorbers. But in this case, we chose the porous material with a very large thickness. This we also tested in the acoustic laboratory if we get sufficient absorption out of this. And perhaps you noticed from the picture that almost the whole space is covered with these materials. Again, you need a lot of sound absorption to control reverberation in a big space. All right. What else is special about this building? This is a nice picture taken during construction. So what you can see is actually it's a completely steel structure building. So all the concrete that you see on the outside is hanging on this structure. And what else is special is that we wanted to create an acoustic separation between the auditorium space that you see on the right, and you already see a part of the roof of this auditorium, and that is connected to the big warehouse space. But we don't want vibrations from the roof into the warehouse. And the solution here was to apply acoustic bearings, so-called acoustic bearings, which are contain of rubbers that create an acoustic interruption. And you can also see that it's a horizontal but also a vertical and a horizontal bearing with acoustic material. And you can see it's quite big compared to the person behind. And when you go into the building and know where to find them, you will see this acoustic bearing here. And it's sitting between two steel beams and the other beam coming from the other side of the auditorium. Quite spectacular, I must say. I never saw this. And it's not just the steel structure that is decoupled. Every concrete panel that you see on the outside of the building is hanging from the steel structure with these acoustic bearings. And if you walk through the spaces around that auditorium, you can see that they are everywhere. And you can also notice that they are different for every concrete panel. So there was a lot of attention went out into detailing every acoustic bearing for every concrete panel. Turned out to be a challenging concept. What else was? I think this is the last topic for this building. Is that we have all these concrete panels, which are nice for sound insulation, but there is a gap between every panel, and that is needed because the steel structure of the building has to be able to move slightly because of the wind loads so you need a flexible connection between every concrete panel. So there's quite a big gap, 5 centimeters, which is considerable for acoustics, and sometimes more. And we wanted to make sure that the sound insulation was achieved with the seals that were applied. So what we did is we made this setup that you see on the left with a crossed gap in a concrete floor in our acoustic laboratory. And there is another room underneath this room, so we can test how the sound is going from the room above through the slits to the room below. And we have tried a lot of different materials to put into these slits to see which one performed good enough for the building. And the final solution was a double silicone seal in every slit. And that was, in the end, kilometers of acoustic seal that went into the building to get everything airtight. Okay, so the building was done, and just a few fun pictures of what you can do with this building. So on the left-hand side, we see the opening show in the big warehouse, but you don't see the space because the designers chose to make a wrap of fabric around this kind of big stage in the middle. So you can do a lot of fun things. On the right-hand side, there's, like, let's say, the more traditional way, sitting in an auditorium looking at the stage. But you can also use this big space for exhibition. And that's what you see on the picture left bottom corner. It's an exhibition of inflatable objects, which are very large, because if you watch closely in the right corner below, there's a big mirror, and you can see me standing in the mirror. So I'm quite small compared to this huge inflated object. And this you can only do in such a big space. Okay, that was what I wanted to share about the factory project. Another project I want to talk about is the milk factory that was transformed into an office building. I found this very nice old picture showing the trucks collecting the milk and bringing the milk in. And on the left-hand side, you see a part of the factory that was renovated now as an office building. So let's have a look at the artist impression, because they are still building. It's not finished yet. They are built at the moment. They are building the two towers that you see in the picture. But on the right-hand side, you already see the old factory. And during the construction, we also went in, and of course, acoustics was a big problem. Again, we have this very big space with only reflecting materials. And clients were very worried about this space. They knew the space was extremely reverberant, and they were scared about the result if there would be a very bad acoustics afterwards. So, of course, we did also acoustic measurements, and a very fun measurement, in my case, I always like these kind of things, is to look for the worst condition. And that worst condition you can find when there is what we call a flutter echo. A flutter echo is a reflection bouncing back and forth between two surfaces. And this kind of echo becomes worse if you have one of the two surfaces is bended, because you can imagine that all the sound is always pressed backwards into this one single location. Okay, so I was on the building site, and I didn't have any equipment at that time. So what I did is I took a wooden plank and I hit it as hard as I could on the floor. And let's have a listen. Okay, let's do it again. So what you hear is this kind of rattling sound. The sound is bouncing back and forth. And when you were talking in these areas, it was terrible. So we changed the space. This is the same viewing angle as before, but now as it is now finished. And you can see the arrows point at all kind of materials that are sound absorbing. We have sound absorption behind plants. We have a ceiling is now covered with sound absorption. And there is this new wooden structure, which is also a wooden slat structure with sound absorption behind. And that creates now a very nice atmosphere. So now we're looking at the same space, but then in our acoustic model. So we, of course, have to also make a prediction of how much the effect of different materials will be in the space. And we use acoustic 3D models that can make that prediction. And you can also see that it is a very abstract version of the space. So all we need is the acoustic properties of the surface. in the space. And all this was needed to also convince the client that we really needed those solutions. Because, for instance, you see the ceiling on the left-hand side. That's the picture of the ceiling as it was before. And actually, the architects, they would like to keep this raw, original version of the ceiling. But there was just no way we could find other solutions that worked enough to get the good acoustics. So here the video starts. You can see that they're spraying material against the ceiling. And it's a kind of paper pulp that dries up and has this, you could say it has a kind of concrete look, especially if you look far away. And after it's sprayed on, they tap the material to kind of fix it, but also make it a little bit more, yeah, a little less rough. Yeah. Okay. Now we often get also the question if plants have sound absorbing properties. And that's not the reason why the plants are here. The plants are here for, yeah, making a nice space for people to work and meet. But the clever solution here was to hide the sound absorbing materials behind the plants, so the sound can go through the leaves and find the absorption behind. Now we move to an office floor in the same building. So we just saw mainly the entrance space. The office floor is like this. With, if you take a close look, you can see that there are a lot of these kind of boxes in the space, and every box is two different concentration booths or booths for making phone calls. And once you make these kind of boxes, you want to make sure that the sound insulation inside, outside, but also sound insulation between the spaces is as good as possible. Besides that, we needed surface area to add sound absorption to the big space because we wanted to keep the reverberation low. And that's what you see on the outside of the boxes, is that we have these big surfaces of sound absorption. And on the picture on the right, you see that the sound absorption actually is a kind of paper pulp material, and that material is wrapped with a fabric. So this is the view into the space. And what is nice here is that this person walking is nicely demonstrating how carpets work in this space, because we always advise that in the routing through the building where people passing by, it's highly recommended to keep strips of carpet so that you reduce the walking noise, because walking noise can be very disturbing in an office space. And then next to it, you also see that there are parts that are just concrete floor. I think it's a very nice combination of both. Okay. Last but not least, the Van Abbe Museum, which was a very nice project because the building was already finished, and it was a building without sound absorption at all. So there was just reflective spaces. And a new exhibition was designed, and once every 5 years or so, the whole exhibition is replaced, you could say. And they wanted to make an exhibition that is more inclusive for sound, but also for vision, all kinds of special features, you could say. So on this picture, you actually see a person that can feel the painting that's hanging on the wall. So they made the 3D objects of the paintings that are on the wall. In this case, Picasso. So that a person that cannot see the picture can still feel what's on the wall. And it's in this case an specially designed carpet that is wrapping the whole room and the ceiling, creating a nice acoustics for this space. Okay, so this is the outside, and this would be a typical example of one of those exhibition spaces that can be very high also. And you can imagine that this is a very reverberant space. And again, we see a banded ceiling and a rigid floor. And of course, you can again expect that we have these flutter sounds. I can play them, and they're a bit softer, so I have to listen carefully. Play it again. Okay, so it's clear that we have the flutter in the middle of the space. And we tried different scenarios to get rid of it. And one is putting a sound absorption on the floor. If you do that, the space is still reverberant, but the flutter is gone. Let's have a listen. Again. Yes, so the reverberation is still there, but the flutter is removed. But of course, you cannot put sound absorption in the middle of the space where you want to put the art objects. That's problematic for the space. So we went and tried a different solution. On the left, you see the picture with the sound absorption on the floor. We tried how the sound, or if the flutter is removed. Well, that was confirmed. We wanted to make sure that the same effect occurs if you put the sound absorption against the ceiling, because that was the idea, to somehow make the ceiling sound absorbing. So we made a setup with a lift to hang sound absorption. And it turns out, yes, it worked. So that was confirmed. And in the end, the museum came up with the idea to replace some of the glass panels in the ceiling with a perforated foil. And that perforated foil is a sound absorbing material. And that was a very nice solution because the flutter is gone and they applied it everywhere in the museum. However, removing the flutter is not enough to reduce all the reverberation in the space. Luckily, the designers of the exhibition also had the idea of carpet in one of the spaces. So this is a very nice example again of integrating a sound absorbing carpet into a project. This is the room I showed before with the fully wrap of carpets all around. However, in some spaces we didn't have carpet, and we did have these kind of cabinets against the wall, and the designers of the space already came up with the idea of having this stripe effect on the walls. So we said, okay, why don't we make this sound absorbing? And we can also hide sound absorption on top of the cabinets. So if you know where to look, you will find the sound absorbing materials on the top of the cabinets hidden, and you don't see it if you don't know it. The stripe on the wall is actually a cushion of 5 centimeter thick sound absorption with fabric wrap. So going back to the space, probably nobody would expect that this is an acoustic solution. All right. It's time to conclude my talk. Thank you very much for listening. Also, I'm happy to answer questions, so I hope you have some good questions for me.
Thank you, Remy, for this insightful talk. Now, if it's okay for you, I'll go over to the Q&A. So the first question is, how do you balance the need for noise control with the durability of materials in high traffic, high energy environments?
So I think the question is about sound insulation from one space to another, right?
Mm-hmm.
And For the example of the performance space, we use this concrete box system for the warehouse. However, concrete is not that sustainable. On the other hand, you could potentially reuse the panels because it's a panel system. You can, in principle, you can take everything off and reuse it as a panel. Um, but what I forgot to mention is that the auditorium is actually a wooden structure. So there's behind these sound absorbing panels, there is a CLT box hidden inside the structure. It's a pity that you cannot see it, because it's always nice to be able to show the sustainable solutions as well.
Mhm.
Um, but there is, in this case, also a wooden inner box in the auditorium. Yeah.
And for instance, the pulp that they put on the ceiling, is that a sustainable solution, or is it made from waste, or is it created um, just
Yeah,
for that?
I think it's created because if it would be, and potentially it could be a reused material, but
Hmm.
then it's hard to control the coloring and things like that.
Yeah.
Um, so the spray is not. I think it's not reused, but the sound absorption that is behind the fabric in these big panels,
Yeah, the
that's all.
blocks.
Yeah, the big
Yeah,
blocks. That's
okay.
all
Yeah.
reused paper. Yeah, and what is fun about the fabric is that it's actually reused clothing from the military.
Oh, that's nice.
Yeah, because they have the same outfits for a certain I don't know, a group. So it's always the same color, and they can
Hmm.
easily reuse it and make a new fabric out of it.
Oh, okay, didn't know that. Thank you. Another question is concerning the milk factory. Concentration isolation boxes were used to improve noise reduction during work. Where does Rimi stand on landscape offices?
Uh-huh. Yeah, good question. The landscape office concept, it's in terms of acoustics, it's of course a very tricky concept because on one hand, you want to communicate well enough, but you also have disturbance by the sound of others. Well, in this case, in the milk factory, there you have a lot of these boxes, and the boxes they also shield the one space parts of the space. Um, so it's not a very open space in a way. You create open spaces and boxes, and you create shielding with that.
So that
That's
with use of zoning. Um,
yes,
yeah, okay.
yeah,
Yeah.
yeah. But I have to admit, it's quite the luxury environment in this case, so it's not
Yeah.
always like this.
No, 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 indeed. And then another question. We almost always see building materials as sound absorption or isolation. Could a completely organic material such as sand also be used?
Oh, that's a good question. Well, then maybe the first question is that whether you would be able to combine a material to be sound insulating and sound absorbing at the same time.
Mm-hmm.
That's usually quite difficult because a sound absorbing material has to be porous. Usually it's a porous material, not always, but usually. Once it's porous, the sound will go through it easily. So then it doesn't isolate sound. So usually you have to combine two things. And you might think of sand as a porous material because that it has these uh, this fine structure. Actually, I never investigated the sound absorption of loose sand. I wouldn't know. But once you may want to make panels, if you want to make walls, for instance, then the sand has to stick together. Huh? So you have to somehow glue it together, or you have to fill you have to fill the cavity with sand. You can do that, but that's a very old trick, I think.
Okay. And then maybe one more question. Can you share innovative strategies for managing sound in atrium-style spaces where traditional acoustic treatments might not be feasible.
Yeah. What is traditional and not traditional? In the end, you need, if the space is large, you at least need sound absorbing surfaces. I don't think you can do without. On the other hand, what is also an interesting thought is that if the space is reverberant, it doesn't have to be a big problem
Mhm.
as long as there are not too many people in the space. So an atrium can also work quite well, even though it's reverberant. But then you don't want to put a restaurant with 300 people in it. But if it's just the traffic zone and a couple of people talking, it can be fine without any acoustic solutions. So it's you also have to think about the functionality, I think.
Okay, okay. Well, I think that's it for the time we have today. So if it's okay, I would like to end the talk here. So thank you again, Remy, for sharing your expertise. Also, thank you for everyone for joining us. As Remy said, this was the last session of our modulyss talks on tailoring acoustics for commercial spaces. You'll receive a recorded version and the Q&A later via email. And if you want to stay up to date on new talks and events, be sure to subscribe to our newsletter. So thank you, Remy, and thank you everyone for joining, and see you next time.
Thank you.
Thank you. Bye.